Okay, so the video is recording already. Recording. Okay, any questions? No, huh? Okay, so what is the equivalent capacitance between point A and point B as shown in the figure 2? You have to you want to find the total capacitance. Okay, so you can see here the combination of parallel and series capacitor. So we work by we combine these two first, okay, to become becoming something like this. Okay, maybe we put this as we combine that. Okay, so we can label it become this is put it as C4, this one is C13, okay, this one is C62, and then this one is C8. Yeah, okay, and then after that I combine these two in a series. Okay, so it become something like this. So this one is C413, this one is C628. Finally we combine this one, it becomes this one. So finally we get the C equivalent. So C equivalent is actually the whole thing. Yeah, C equivalent is actually the whole thing. Okay, so we do step by step lah. Okay, so first we find C13, yeah, 1 and 3, C13. So how to do that? Yeah, sorry, this one is CAB lah. Yeah, the C equivalent is CAB. CAB across the whole thing. CAB. We can put this as CAB also. All right. So C13. Okay, 1 and 3 they are parallel. So C13 is equal to C1 plus C3 parallel. So it is equal to 4 microfarad. So you got it. Okay, 4 microfarad. Okay, next, between 6 and 2, so same thing, C62 is C6 plus C2, they are also parallel. Okay, so 6 plus 2 is 8 lah, 8 microfarad. Okay, so we got it ready, C13 and C62. Now we combine these two in series. This one also in series. So in series is 1 over C. Yeah, we use 1 over C. 1 over C413 is equal to 1 over C4 plus 1 over C13. So is C4 is 4 micro, C13 is 4 micro also. Oh, okay. So this is C413. So C413 is equal to, okay, what do you get? So you get 2 over 4 micro. Okay, so you need to invert it. Okay, because you got 1 over C. To get C, you need to invert it. Yeah, remember to invert it. -1. Yeah, so that means when you invert it, it becomes 4 micro over 2, which is equal to 2 microfarad. So we got it. Okay, we got 413. Now do the same for C628. So also in just now is in series. So C628 also in series 1 over C62 1 over C8. Okay, this one in series 1 over C. Okay, so 62 is 8 micro. Yeah, 8 micro, and then C8 8 micro. Oh, so to find C628, you need to invert lah. You get 2 over 8 micro, invert it, so it become 8 micro over 2, which is 4 microfarad. 4 microfarad. Okay. Lastly, combine them in parallel, so we get the C equivalent. So C equivalent is C413 plus C628 in parallel. So 2 micro plus 4 micro, so you get 6 microfarad. So that's it. 2 plus 4, you get 6. That's the answer. Yeah. Right. So is that the answer? Question 3. Let's check. Yeah, 6 microfarad. That's correct. CAB, 6 microfarad. Okay, it's correct. Okay, so that's it for question 3. Okay, you got it, class? Got it, huh?
Yes, sir.
Okay, now so let's move on. Yeah, let's move on. So we have finished this question. Now the next thing is apply energy stored in capacitor. So we know that capacitor store electric potential energy. Yeah, a charge capacitor store electrical energy. The energy stored in a capacitor will be equal to the work done to charge it. Okay, work done to charge it equal to the energy stored in capacitor. So when the switch is closed, charge begins to accumulate at the plate. A small amount of work done is done to bring a small amount of charge from battery to the capacitor. Okay, so this is the work done. The work done equal to the energy store. So we can say W equal to U. Okay, work done equal to V delta Q. So V is actually Q over V. C is Q over V, so V equal to Q over C. So we substitute Q over C into the V here, and then integrate from charging the capacitor from 0 charge to maximum charge Q. So we integrate. C is constant. C is constant, so can be taken out. So integrate Q become Q square over 2. Yeah, Q square over 2. So that's why the formula become half Q square over C. So energy stored in capacitor is half Q square over C, or half CV square, or half QV. Do you know how we generate the other three formula? So you can look at here. Yeah. So energy store. Yeah. Energy stored in capacitor is actually the work done equal to the work done to charge. Work done to charge it. Yeah, work done to charge it. So U equal to W lah. Okay. So formula is start from half, from the derivation we get half Q square over half q squared over c. Okay, half q squared over c. This is the formula, half q squared over c. And we know q equal to cv, correct or not? So we can substitute q with cv. So we get c squared v squared over c. So can cancel the c. So we get half cv squared. So that's the second formula. We get half cv squared. And then half qv is, we don't want the c. Yeah, we don't want the c. So that means c is equal to q over v. Change the c into q over v. So half, this one is q over v, c is q over v, v square. So cancel the v. So that's how we get half qv. So there are 1 formula, 2 formula, 3 formula. Okay, this is the energy stored in capacitor. Energy stored, yeah, in capacitor. So you can put energy stored in capacitor. Now, okay, class. Next is this one. From the formula above, the energy stored in charge capacitor is half the energy produced by the battery. Okay, so energy stored in capacitor is half qv. Okay, half qv. Energy produced by battery is actually q multiply v. Yeah, you go to qv. So actually there is an energy loss inside the capacitor. Energy loss inside the capacitor is actually take the energy produced by the battery minus the energy stored in capacitor. Okay, what does it mean by this? That means if I have when I charge a capacitor, look at this circuit. Yeah, look at this circuit. This is a capacitor. Okay. Okay, probably there's a switch over here. Okay. So when I close the switch, then it start to charge a capacitor, isn't it? Charge a capacitor. So this is the battery. Okay, and this is the capacitor. Okay, battery do energy produced by battery is q multiply v. Okay, energy produced by battery is energy produced by the battery, or okay, say energy by the battery is qv, and energy stored in capacitor is half qv. So where is the rest of half qv? Another half of the energy, where does it go? So actually it's like this. Energy produced by the battery is equal to energy stored in capacitor. Yeah, energy stored in capacitor plus energy loss as heat. Yeah. So energy produced by battery is actually qv. Energy stored in capacitor is actually only half of it. So the other half lost as heat. The other half lost as heat. Okay, battery produce this amount of energy. Only half of it is stored in capacitor as electric potential energy. The other half lost as heat. Okay, class? Yeah? Okay?
Okay, sir.
Yeah. Okay, so that's it for energy part. So I want to go to the tutorial questions. Please look at question 4. Okay, let's do question 4. So okay, so you are given 3 microfarad capacitor fully charged to 28 microcoulomb after connected to a battery. Calculate the energy stored in capacitor. Okay, so the question asks for energy stored in capacitor. That means he asked for energy stored. Okay, given you 3 microfarad, this one is capacitance value, fully charged to the 28 microcoulomb. This is Q. So how to find energy store? Very simple, just a formula, just use the formula. Energy stored in capacitor is half QV or half CV square or half Q square over C. Remember this. Where is it? The notes. Remember these notes. Yeah. Energy stored in capacitor. I also have derive for you to see. Saya pun sudah derive untuk kamu tengok. Mana sudah derivation saya? Saya sudah derive. Half Q square over C, half CV square, half QV. Okay. Okay. So kita ada charge and also capacitance. So which formula do you use? Half Q square over C. So use that formula. Half Q is change to SI unit. 28 micro. Micro means negative 6 coulomb. Q square over 28 micro over 3 microfarad. That means negative 6 farad. Okay, use our calculator. Yeah, half Q square over C. Yeah, use your calculator. So 28 exponent negative 6 square divide by 3 exponent negative 6 divide by 2. Yeah, so the energy stored is a second, 1.31 exponent negative 4 joule. Okay, 1.31 exponent negative 4 joule. So is that correct? Let's check. So just now is question 4. Yeah, energy stored is 1.31 exponent negative 4 joule. 1.31 negative 4. 1.31 negative 4 joule. Okay, good. Now, what is the energy stored if the same capacitor have been connected to 8-volt battery? So what formula should we use to find the energy stored for the question B? He says same capacitor kan? Same capacitor, that means it use the same C. C value is constant. But different voltage. Different voltage, that means V different. Only the C is constant because using same capacitor. Okay, so now let's do it. Question B. Energy stored in capacitor is half. What do you think you need to use? Use a C value, same C value, 28 microcoulomb. No. 3 microfarad. Use that one. Half C, and then connect to 8-volt battery. 8-volt battery. So half CV square lah. 8-volt battery. So half same capacitance. That means same farad. -6 farad. So 8-volt battery. So what's the answer? Remember to have square. This one got square. Half CV square. So 8 square divided by 2 multiply 3 exponent -6. Yeah, so the answer is 9.6 exponent -5 joule. Okay, is that the answer? 9.6 -5. Is it? Where's the answer? Where's the question again? Half CV square. Question 4. Question 4. Yeah, correct lah. Yeah. This one is 96.6. Because I put it. This one is more than 10. Okay, my one is less than 10. 9.6 exponent. Okay, if we become 9.6, here become -5. Yeah, because plus 1. So become -5. -5. Yes, correct. Energy stored, joule. Okay, joule. That's correct. This one also. Okay, so next. Yeah, charging and discharging capacitor. Okay. Class, take 5 minutes. Just for a while. I need to have some drinks. Just a 5 minutes break. Okay. Okay. So now I'm continue recording. Okay, recording. So now, so the next part we are going to learn is charging and discharging of capacitor. Okay, charging and discharging. So what is the meaning of time constant? This is the formula for time constant, RC. Then there are two graphs that we need to learn. Charge time. We need to sketch and explain characteristics of charge time and current time graph for charging and discharging capacitor. And then we also use the formula, this formula to find out the charge for discharging capacitor and also for charging capacitor. Okay, so let's dive into it. So equation of time constant. Okay, the equation of time constant, very simple, is equal to RC. Okay, RC. So the quantity RC appears in the exponent for all equations. That appears in exponent of all equations is called time constant. Symbol tau. Yeah, we call it tau, or relaxation time of the circuit. Okay, it's a so time constant is a time. Yeah, it's a time. So the unit is second. That's why it's second lah, because it's time. It's a time actually. Okay, the unit is second. It's a scalar quantity. It's not a vector. It's a measure of how fast the capacitor charges or discharges. So that means if a small value of time constant, if the time constant is small, then it's short time. Short time capacitor charge or discharge. Yeah, very short time. That means the capacitor charge very quickly or discharge very quickly. If the time constant is long, that means the capacitor take a long time to charge and long time to discharge. Okay, so it's a measure of how fast or how quickly the capacitor charges or discharges. So time constant is affected by two factors: resistance and capacitance. Resistance unit is ohm, capacitance is farad. Why is it time constant affected by resistance and capacitance? I will explain about this later on. Yeah, I will explain about this. And you can see definition of time constant. There are several ways to define time constant. And to define time constant, it is different. If you want to define time constant, yeah, for charging process and discharging process, different definition, different. For charging process, we use 63% or 37%, but for discharging, it's always 37%. So there are some differences, which I will explain later on. Okay, charging process and discharging process. Okay, and the graph. Okay, I will explain. Okay, so first of all, what I want to explain here is, of course, the formula time constant. Okay, but before that, let us just look at what is actually charging and discharging process. Yeah, what actually happening? Okay. Okay, maybe I just draw it out and we can see more clearly. Okay, charging and discharging process. Okay, so let's start with charging process. Yeah, charging charging process. Charging process. Now, you are given a capacitor and connected to a battery and also passing through a resistor. Okay, maybe I think I should put the resistor over here. Yeah. Okay. I think I should put it over here. I think capacitor, I should put it over here. Okay, better. So you have resistor, capacitor. Okay. So this is the battery with total voltage. Like that, yeah. If you look at this one, this is actually a RC circuit. This is a RC circuit. RC circuit means what? Resistor with capacitor circuit. Yeah, resistor with capacitor circuit. RC circuit. Okay. So like this, initially, before the capacitor is being charged, okay, before I want to go any further, I want to put it this way: the V across the capacitor, you have voltage for capacitor. Across the resistor, we have voltage for resistor. Okay, so V total is actually VC plus VR. Correct not, class? Because they are series. Okay? Understand? Oops. Okay. So V total is actually capacitor voltage plus resistor voltage. Okay? And initially we can say, let's say initial voltage is let's say 10 volt. 10 volt. Yeah, 10 volt. Initially, the capacitor is neutral, uncharged, not charged at all. Okay, so the across the capacitor, I should say, initially it is 0 volt. 0 volt. But for resistor, it take out all the voltage, 10 volt. Okay. Initially, capacitor is uncharged, not charged. So the potential difference across the capacitor is only 0 volt. So that means all the voltage is only taken by resistor. So I can say it's like 10 volt equal to 0 volt plus 10 volt, like that lah. Okay, so capacitor initially uncharged. Okay, initially, yeah. So let me write it out. Capacitor initially uncharged. Okay, uncharged means initially uncharged, that means Q near 0, voltage capacitor pun charge capacitor 0, voltage for capacitor also 0. Okay, initially uncharged. So resistor has all the voltage. Okay, but afterwards, when it start to charge, yeah, because we know that this is a positive plate, this is a negative plate. Okay, then electrons start to move. Electrons start to, this positive plate start to attract electron from this plate. So electrons start to, move from this plate of capacitor, start to move and deposit at the positive terminal. Electrons start to flow from this plate of capacitor and deposit at the positive terminal. Okay, so this plate loses electron. Understand? It loses electron. So it start to become positive charge. Understand? It start to become positive charge. Why this plate become positive charge? Because it loses electron. The electron is attracted to the positive terminal of battery. So after that, electron also flow from negative terminal. Electron also flow from negative terminal and then across the resistor and deposit at this plate. So it become, so this plate become gain electron. It gain electron from the negative terminal, so it become negative charge. Understand, class? So what I want to say is, it start charging already. Okay, initially the charge is 0, but then it start to build up charge. The battery will charge the capacitor slowly. Yeah, start to charge it up. So that means the voltage across the capacitor will start to increase. Should put it, how should I put it? Let me put it this above a bit. So it start to charge it, become, this one become 1 volt already. Capacitor become 1 volt. So the resistor become only 9 volt. Understand? Become 9 volt. Because it's always like must be 1 volt plus 9 volt. The total must always equal to 10. Yeah. When that means the voltage of the capacitor start to increase and the voltage for resistor start to drop. When the charging happen. Okay. So the from 0 become 1. This one increase, capacitor increase, but the resistor start to decrease. And then let's say the capacitor charged to 2 volt. Capacitor charged to 2 volt. What happened to the resistor? It dropped to 8 volt. This one charged to 3 volt. This one becomes 7 volt. The total must be 3 plus 7 must still be equal to 10. Understand? So this one start to drop and this one start to increase. Finally, class, this until this process will continue until the capacitor become fully charged. Capacitor become fully charged. It only stops when capacitor become 10 volt. It take out all the 10 volt, and resistor left with how many volt?
0.
0. That's correct. It left with only 0 volt. Finally, resistor only has 0 volt. Okay. So that's how, yeah. When the capacitor is fully charged, become 10 volt, the resistor become only 0 volt. Okay, you see, this is very important. I will explain later. Yeah. Okay. Okay. Okay lah. Just don't rub it off yet. Okay. So the graph is like this, class. I just want to draw the graph for you. You know, I want to draw the graph for you. Okay. This is what happened in capacitor, and this is what happened in resistor. How should I draw it? Right. Okay. Voltage. This is what happened in. Okay, I want to draw. This is for capacitor. Capacitor. This is what happened in the resistor. What happened in resistor? Okay. So now, look at the graph. Yeah, look at the graph. What I'm sharing here is not really in the notes, right? Because I'm teaching you something even more detailed here. Yeah. Because in the notes, he never discussed what happened to the resistor. He just discussed what happened to the capacitor, right? Okay. But what I'm teaching you is something extra. I also teach you what happened in the resistor. Okay. So I want you to see what happened. Okay. So the voltage, just now talking about the voltage of capacitor. And this is the voltage for resistor. Okay. So it's something like this, class. Something like this. I need you to know this. Yeah. I need you to know this. Initially, things like this happen in the capacitor. Initially, capacitor is 0 volt. Initially is 0 volt. And then but the capacitor is 10 volt. Like this, yeah. Initially capacitor is 0, but the resistor is 10 volt. This 10 volt, I just give the value lah. Yeah, you just give the value. So this is actually what happening. For capacitor is increasing until it reaches when it's charging. Yeah, this is the charging process. So the voltage increase until it achieves 10 volt. But for resistor, the voltage decrease until it becomes 0. It decreases until it becomes 0. But total up still 10 plus 0 must equal to 10. Cannot be more than 10. Yeah. The total voltage is still 10 volt. It's just that when we charge a capacitor, the voltage for capacitor increases until maximum. The voltage for resistor decreases until becomes 0. Okay. And talking about the charge, now I want to talk about the charge also. Yeah. Talking about the charge in capacitor. Charge in capacitor also increase. Yeah, initially it's uncharged 0, and then it become increase until he reaches a maximum value. We put this as a Q naught, maximum charge. We don't know what charge, but just put as Q naught. Actually, and then this one we can put also as V naught. Yeah, for the maximum voltage as V naught. In charge until maximum, initially is uncharged, and then charge until maximum will become Q naught. Resistor don't store any charge. Yeah, the resistor don't store any charge. just have the voltage graph only. Okay. Now the next thing is the current graph. Yeah, the current. What happened to the current in the circuit class? What happened to the current in the circuit? Just now talking about you know, charging the capacitor. Charging capacitor means there are electron flow in the circuit. Correct or not, class? Electron flow. Got electron flow, you know, electron flow from this plate. Okay, this plate, the left plate, go to the right plate. You see that? Yeah. This plate. Yeah. Look at the green plate. The green plate, it loses electron when charging capacitor. The green plate loses electron. So it becomes positive plate. Loses electron, and then this electron move to the other plate. Go to the, let's say, the blue plate. So the blue plate gain electron. So it become negative plate. So when charging the capacitor means got flow of electron. Kan? Correct or not, class? When charging the capacitor, we have to charge the capacitor. That means in the circuit got flow of electron. Okay. On the right there, got flow of electron. So flow of electron charge. So flow of electron actually is the current. Correct or not, class? Yeah, got current in the circuit. But current is considered as a positive charge lah. Opposite the negative, opposite the electron. Yeah. So current actually flow of, what I can say, got flow of charge. Flow of charge in the circuit is current. Yeah. Flow of charge in the circuit is current. Okay. Class, I want to ask you, class, in the charging process, the circuit got charge flow or not? The circuit got charge flow or not? When charging the capacitor, got any charge flow in the circuit? Yes or no? Got charge flow in the circuit to charge a capacitor? Yes or no? Yes, that thumbs up means yes. Yeah.
Yes.
So got charge flow in the circuit. Yeah. What I say, electrons is pulled out from the green plate and deposit at the blue plate. So this green plate loses electron, it becomes positive charge. This blue plate gain electron, so it becomes negative charge. So that means in the circuit got current. In the circuit got current when charging process. Yeah, when charging process happen. When charging process happen, the circuit got current flow, got charge flow. Because got flow of charge in the circuit, means the circuit got current. Ada arus. Ada arus dalam litar ini. Kenapa ada arus dalam litar ni? Sebab ada charging process. Ada charge flow in the circuit. Got electron flow in the circuit. Understand, class? Understand? Give me a thumbs up if you understand. Yeah. So, since got current in the circuit, so I want to ask you, what happened to the current in the circuit actually? What is the graph? What is the graph? Maybe we put another graph for the current, right? We put another current for the graph. You know why I teach you about resistor? You know why? because this voltage across resistor is corresponding to the current in the circuit. Pernah tengok formula ini, VR equal to IR, Ohm's law? Pernah tak? VR equal to IR, ingat tak formula ni? Nak tengok you punya tangan. Ya, tangan you cantik lah. So yeah, VR equal to IR. Yes, betul kelas. VR equal to IR. Okay? VR equal to IR. So, tengok when charging process, this is a charging process. Should I draw right? Charging process. Should put it here. Charging process. Okay, charging process. Put it like the shape. Charging. This is a charging process. Okay. Now, what happened to the current in the charging process? What happened to the current? Adakah what I mean is current itu current arus itu arus. Apa itu arus? The flow of charge in the circuit. Okay. Arus ini, what I want to ask is semakin bertambah atau semakin berkurang? Semakin bertambah atau semakin berkurang dalam charging process ini? Adakah dia semakin bertambah atau semakin berkurang? Charging. So charge semakin bertambah. So you punya jawapannya lah current pun semakin bertambah. Betul ke? Betul ke? Betul kan? Is it current semakin bertambah dalam circuit? Ya? Is it? Tidak tahu kan? Tengoklah Ohm's law. This, you know, what I'm doing is I'm using another way to explain. There are many ways to explain this situation, but I use another way. I relate it to resistor. Okay? Look at Ohm's law, class. Kalau resistor punya, as the charging process goes by, what happened to the voltage across resistor? Semakin kurang kan? Sebab capacitor ambil semua voltage itu 10 volt kan? Ya? Capacitor semakin bertambah 1 to 10 volt. Until it fully charged, it become 10 volt. But resistor becomes only 0 volt. Okay? Sebab V total equal to VC plus VR. Kalau VC semakin bertambah, ini akan jadi semakin kurang. Ya? VR become lesser. Okay? So now, as time goes by, voltage across resistor berkurang. Ya? Semakin berkurang. So what happened to the current? What happened to the current, class? Resistor is constant. Resistor masih resistor yang sama. I want to see your hand also lah. I want to see, you know. As time goes by, I cannot show it concurrent. Never mind. As time goes by, voltage resistor semakin berkurang. So that means current also semakin berkurang. So adalah salah kalau kata charging process, current semakin bertambah. Salah. Voltage across resistor semakin berkurang. That means current also semakin berkurang. That means the current drop. Just like the voltage across resistor. V equal to IR. Remember the formula, V equal to IR. No. Understand, class? You cannot find this explanation anywhere. You cannot find it because I myself think of this because I done experiment using Arduino for, you know, the microcontroller Arduino. I done the experiment using that microcontroller to study about this process, and this is the graph I get from the Arduino. Yeah. So I found out that voltage across resistor decreases. That implies the current also decreases over time. Yeah. The current decreases over time. So when charging process happen, the current actually drop, not increase. It actually drop, just like the voltage across resistor, because V equal to IR. Understand, class? You understand? Okay, put it simple like this. Put it simple. Yeah, probably you still don't understand why current drop. Put it like this lah, class. Actually, things are very simple. Don't make it complicated. See, see the whole picture. I want you to see the whole picture. Mula-mula charging, of course, got current, kan? When capacitor is neutral, of course dia want to charge a capacitor, so memanglah ada arus bergerak dalam circuit, memanglah arus maksimum. But when it become fully charged, yeah, so arus memang maximum at the beginning, yeah, it really maximum at the beginning, because capacitor is uncharged, so of course current is maximum at the beginning. Yeah, so a lot of charge flow in the beginning. Okay, but once the capacitor is fully charged, almost fully charged, the current stop lah. The current stop flowing. Yeah, no more current flow in the circuit already, because why no more current flow in the circuit anymore? Because already fully charged. When fully charged, the current stop flowing. It's just like macam you charge your handphone, kan? You charge your handphone. Mula-mula you punya handphone's battery zero, of course a lot of current. But when your battery already 100% charge, your handphone already 100% charge, current itu bertambah banyak ke? Atau dia stop? Atau dia cut off? Ya? You bayangkan lah your handphone. Sudah fully charge. Adakah arusnya semakin banyak? Oh, semakin banyak lah. Oh, arusnya bukan berhenti. Arusnya semakin banyak. Tak pergi ke handphone kamu, sehingga you punya handphone explode. Overcharge. Which one, class? Oops, okay. Suara saya bergegar sampai itu periuk pun turun, ya. Pun apa? Jatuh. Okay. So you see, of course the okay, of course, the current stop flowing. What I can say is beginilah, class. Current stop flowing. Current stop flowing means I become zero when capacitor fully charged. Betul tak? Bukannya semakin banyak. Oh, macam mana you punya plug? You connect your handphone to the plug. Dia sudah your handphone, yeah, your handphone already become 100% charge, and then bila sudah 100%, current dia maximum. Wah, current dia apa? Maximum. Lagi banyak current pergi ke handphone kamu. So kamu tunggu kebakaran sajalah, ya, kebakaran berlaku, kan? So tak logik kan? So should be, kalau sudah fully charged, current becomes zero. Okay, current becomes zero when capacitor fully charged, current stop flowing. Begitulah, kelas. Begini. Kamu pernah pergi ke tandas tak? Pernah pergi tandas? Siapa tak pernah, kan? Okay, saya ambil contoh lah. Saya ambil contoh macam ini. Kamu tahu tangki air? You know water tank, kelas? Water tank. Kamu pernah flush toilet, kan? Selalu flush toilet, kan? Okay, flush toilet. Okay, water tank lah. Just take a water tank. The water tank, you apa? Ya, water tank tu yang apa? water tank lah yang kamu guna untuk flush lah, flush your toilet tu, your toilet bowl, toilet bowl. Situ ada air masuk kan, betul tak? Ada air masuk di sini kan, dan sini air keluar kan, betul tak? Correct not kelas? So begitulah kelas. So you boleh bayang macam ini. You boleh bayang macam ini. Okay. Boleh bayang water tank, yeah, you know, water tank. I write this. This is the water tank for your toilet bowl. When you sit on top of the toilet bowl, you buat business kamu kan. So this water tank, put this as a, let's say, empty water tank. Empty water tank is like an uncharged capacitor lah. Uncharged capacitor. Uncharged capacitor kan, uncharged capacitor. So bila empty water tank, kalau water tank itu empty, uncharged, of course air banyak masuk, betul tak? Air banyak masuk, atau tak ada air langsung kelas, ya? Kalau water tank become empty, of course banyak air masuk. Air itu maksudnya ialah current, betul tak? Air itu macam current. Understand? Air itu macam current. Air itu macam current. So when empty, uncharged, and uncharged means what? Uncharged means kena bagi step dia. Macam mana? Mungkin buat beginilah, ya. Kena buat beginilah, ya. This is the initial, okay. Sorry ya, and this is final, sorry. Okay. Okay, this is final, okay. So this is empty water tank. This is for full water tank. Full water tank. Full water tank means a charged capacitor. The capacitor is fully charged. Yeah, charged capacitor. A full water tank. This one is empty water tank. Okay. Begini kelas. Kalau ini sudah full water tank, macam mana? Full water tank dia. Full of water. Full water tank. This is fully charged. Fully charge. So boleh kata initially empty water tank is uncharged particle, is like uncharged capacitor, is like initially Q dia adalah zero. Voltage capacitor, Q capacitor adalah zero. Tapi air banyak masuk. So current masuk is maximum. Equal to I naught. Understand? Equal to I naught. But for when it's full water tank, that means the capacitor is fully charged. That means the capacitor charge is maximum already, or Q naught. Okay, voltage across capacitor also maximum, fully charged V naught. But current, adakah air masih masuk kah kelas? Ada air masih masuk lagi? Ada air masuk lagi? Tidak kan? Air sudah berhenti. Takkan air masuk lagi? Kalau air masuk, banjir lah you punya toilet. Ya, banjir. Kalau air sudah masih masuk, itu maksudnya capacitor itu sudah rosak. You punya water tank sudah rosak, kena ganti. Air mesti berhenti. Kalau tidak berhenti, dia melimpah. Kalau you punya handphone masih charge, explode lah, kebakaran lah berlaku kan. So kalau sudah maximum charge, dia patut current dia sudah berhenti, menjadi kosong kan. Air tak masuk lagi. Air tak masuk sudah. Air sudah berhenti. Kan dia ada tu pelampung. You got the float, isn't it? Ada pelampung, berhentikan air masuk. Macam itulah. Sebab when almost full, itu punya pelampung sudah macam nak berhentikan air tu. Macam until finally fully charged, air sudah completely tak masuk sudah. Kecuali punya air tangki tu rosak kan. So current becomes zero finally. Understand class? Do you understand the ni apa contoh ini? Boleh faham? Charging and discharging capacitor boleh faham class? Nak tengok tangan. Tangan you banyak lah. Saya suka lah banyak tangan ni. Thank you. Okay. Baik. So how about discharging Discharging bolehkah kamu just a few more minutes, just 5 more minutes. I want to finish off the just the graph. Give me more 5 minutes lah, 5 minit. Lagipun kita dah amali 2 jam kan. Okay. Sekejap lah, 5 minit je ya. Boleh. If anyone want to go to toilet, wait 5 more minutes ya. Okay. Discharging process. What happened to discharging process? So you understand this one? Okay. Discharging process, sekejap je ya. Ini habis sekejap saja. Want to complete the story kan? Takkan ada orang yang cakap cerita berhenti tengah jalan kan? Tak syok. Begitulah. Discharging capacitor. Apa terjadi kan kelas? Discharging capacitor. So kalau discharging capacitor, apa kita buat? Kita buangkan bateri. So capacitor tinggal apa? Sebab if charging process, we need the battery to charge a capacitor. Kalau discharging process, we throw away the battery, we throw away the battery, just the capacitor and resistor. Mesti ada resistor. Kalau tidak ada resistor, dia short circuit. Okay. So begini. So discharging, dia tinggal ada, dia buang bateri itu. Tinggal resistor je. Tinggal resistor. Tak ada bateri sudah. Okay? Tak ada bateri sudah. Ya. Resistor tu, bateri tu sudah buang. Maksudnya, dia sudah jadi, you boleh lukis resistor ke bawah. Macam ini. So it's the same class. Sama tak dua benda ni? Is it this circuit and this circuit is the same? Same. Resistor di sebelah ini actually macam di bawah. So this capacitor and resistor, they are actually, you nampak macam series kan? Capacitor and this resistor macam apa? Series. Is it series class? Is this capacitor and resistor in series? No, they are not in series. They are in parallel. They are in parallel. Tadi class, this one. This resistor and capacitor in series or parallel? They are in series. I want you to take note about this one. This capacitor and resistor and the battery. These two they are in series. In series. Yes, they are in series, not parallel. Sebab dia cuma connected in satu kaki saja. Satu kaki sambung. Kaki yang lain itu sambung bateri. So these two are in series. Tapi kalau sudah buang bateri, menjadi ini, dia bukan series sudah. Resistor dengan capacitor bukan series. They are not in series anymore. Because dua kaki sudah sambung, satu kaki sambung, kaki yang lagi satu sambung. So they are no longer in series. They are in parallel already. Sebab kaki ini dengan kaki ini sambung, kaki ini dengan kaki ini sudah jadi sambung. So they are in parallel class. Nampak tak class? Where's your hand? Didn't see your hand. Okay. This resistor and this capacitor in series. You know why in series? Because hanya satu kaki saja. I mean, macam ini, kaki kanan dengan kaki kiri dia sambung. Tapi lagi satu kaki tak sambung, sambung benda lain. So ini dua adalah in series. Okay? Tapi kalau saya buangkan bateri ini, dia bukan series sudah, dia jadi parallel sudah, itu cerita dia. Okay? Kalau saya buangkan bateri ini, kalau ada bateri ini, dua ini adalah siri. Tapi kalau saya buang bateri ini, dia jadi parallel. Sebab ini resistor macam boleh letak di bawah kan. So you can see the other leg, they also connect each other. They become parallel. Very important class. Okay, cukup. So I want to continue. I need to continue. I have to, yeah. So begini kelas. Begini. So this is voltage across capacitor. This is voltage across resistor. Discharging capacitor, we start with capacitor sudah fully charged. Tadi apa? Tadi tiada charge sampai maksimum kan? Dulu tiada charge, sekarang sudah ada charge, ya, charging capacitor. So sekarang capacitor ini already fully charged and now he want to discharge. Okay, so this is actually a fully charged capacitor. Fully charged capacitor. So this is a positive, and this one is negative charge. Negative charge, so negative class. Negative. Yeah, fully charged. So it's fully charged. Dia ada charge. So sini positive Q, sini negative Q class. Okay. Fully charged. So okay, saya nak buang sajalah. Sekejap. Saya tak apa, saya copy dulu. Ya, saya tak mau buang ya sebenarnya. Banyak benda saya tak mau buang. Saya buat semula di sini. So just nak buang benda-benda ini dulu sebab saya nak sekejap. Saya ada benda yang saya nak. Okay, class. Now I want to begini kelas. Fully charged. Now, dulu electron flow in which direction? Anti-clockwise kan? Betul tak? Electron flow anti-clockwise. Okay, electron flow anti-clockwise. What happened? Okay. So electron flow anti-clockwise to charge a capacitor. Now let's say, remember electron flow anti-clockwise. Now I want to discharge a capacitor. If no more battery, that means I want to discharge a capacitor. That means charge now this positive plate will start to attract electron from the negative plate. That means electron akan mula mengalir. Dari sini, dari negative plate pergi ke positive plate. Now become what? The electron become clockwise. Nampak tak? Kenapa sekarang electron clockwise? Sebab dia sudah tak ada bateri. Sekarang positive plate connect directly to the negative plate. So of course the positive plate will attract electron from the negative plate, and so electron will come out from the negative plate and then neutralize the positive plate. Do you see that? Dulu electron anti-clockwise, sekarang electron clockwise. So dia sudah ubah arah. Correct not, class? Correct not? Correct not? Current sudah ubah arah. Nampak tak kelas? So the current changes direction. Dulu current, dulu elektron bergerak dari plate ini, plate hijau pergi plate biru. Sekarang elektron bergerak dari plate biru balik plate hijau. Discharge lah. Discharging capacitor. Discharging capacitor. So the current change direction. Understand, class? You understand that one? Understand, Okay. So that means sebab dia nak neutralize the, dia nak jadi neutral balik. Okay. So class, so sekarang dia punya equation ni lah, dia punya equation adalah begini. Parallel kan? Ini voltage capacitor dan resistor adalah parallel kan? So kita boleh kata VC adalah sama dengan VR. Dia sama dengan VR. Tapi sekarang dia discharging process. Discharging process means apa? Dulu dia sudah charge sampai 10 volt. Dia sudah charge maksimum sampai 10 volt. Ya, 10 volt. Dia capacitor sudah dapat 10 volt. So sekarang dia punya capacitor sekarang mula dengan 10 volt. Mula dengan apa? Mula dengan 10 volt. So capacitor 10 volt tapi dia parallel dengan resistor. Parallel dengan resistor. So resistor pun ialah 10 volt. Sebab dia parallel. Voltage dia sama, parallel. Ya. Capacitor mula dengan 10 volt. Tetapi sebab dia discharging. So dia akan menjadi kurang. Dia akan semakin berkurang. Capacitor punya voltage semakin berkurang. So resistor voltage also semakin berkurang. Okay. So that means the capacitor, the capacitor start from apa? Begini. It start from maybe 10 volt. Initially this one 10 volt, this one also 10 volt. Tapi capacitor discharging process happen. Discharging. Okay, I should write discharging. Sinilah baru nampak Baru nampak. Begini. Discharging process. So dari mula-mula 10 volt tapi dia discharging semakin berkurang lah, 9 volt, 8 volt. Bila capacitor jadi 9 volt, resistor punya voltage pun menjadi 9. Bila capacitor become 8 volt, resistor pun dapat 8 volt. 7 volt, 7 volt. Akhirnya when fully discharged, capacitor become 0. So dia punya resistor pun menjadi 0. Fully discharged. Understand? Become 0. So voltage capacitor semakin kurang, resistor pun semakin kurang. Okay, let's draw the graph, class. Let's draw the graph. Okay. Let's draw the graph. Let's draw the graph. So start dengan apa? Charge dulu lah, charge of capacitor sebab dia discharging. Okay, discharging. So start dengan maximum fully charge. Dia start actually dengan Q0 fully charge, tapi dia semakin berkurang kan sebab discharging process Q semakin berkurang, semakin berkurang. Okay. Kalau Q semakin berkurang, what happen to the voltage? Voltage pun semakin berkurang. Begini ya. Okay, saya kena tu lukis sekejap charge. This what happen to the. Okay, I should write. This is the capacitor. This is the resistor. I should put it this way. This is the capacitor, and this is the resistor. Begini, ya. Okay. Resistor tak ada charge lah. Capacitor got charge, but sebab dia discharging process, discharging. Okay. Discharging capacitor. So charge makin berkurang, kelas. Semakin menjadi kosong sampai dia jadi kosong lah. Sampai dia jadi kosong. Okay. So charge makin berkurang. What happened to the voltage? Mula dari 10 volt berkurang menjadi kosong sebab discharging. Sebab elektron start to flow clockwise sudah. Dulu anti-clockwise, sekarang dia clockwise to neutralize the charge. Negative pergi ke positive to neutralize the charge. So 10 volt becomes 0 volt. So dia punya voltage makin berkurang juga. When charge berkurang, voltage pun berkurang. Okay. Okay, I almost finishing ya. So voltage of capacitor pun semakin berkurang kelas. Dari V0 dia 10 volt berkurang menjadi kosong juga. Begitu ya. Jadi kosong. Now, how about resistor? Ya, resistor pun sama lah. Resistor pun sama macam dia. Resistor pun sama, voltage resistor time. Dia pun mula dengan V0 dia pun 10 volt kan? Sebab dia parallel. Why VR same as VC? Sebab dia parallel. Parallel memang voltage dia sama. Dia ikut voltage capacitor. So it start from 10 volt, also decrease, become 0. Understand? So class, what happened to current? Lastly, what happened to current? Also kita tengok Ohm's law sahaja. Kita tengok apa? Ohm's law, V equal to IR. Understand this formula? V equal to IR. What happened to the current? V equal to IR. VR equal to IR. Ohm's law. Okay. So, discharging process, VR semakin berkurang. VR semakin berkurang. So, what happened to current? Semakin berkurang juga. Semakin berkurang. So, it follow the graph of resistor. Understand? Current semakin. Lukis di mana? Ya, saya lukis di sini sajalah. Saya lukis di sini. Sebab dia tengok resistor punya. Dia tengok resistor. Sebab follow formula Ohm's law. V equal to IR. So, current punya graph adalah kurang juga. Start from maximum I0. Kurang menjadi kosong. Begitu kelas. Semua graf berkurang. So tengok current kalau current tak pernah ada yang tambah kelas. Kalau charging current berkurang ya, current berkurang. Kalau discharging pun current pun berkurang. Tahu kenapa kelas? Current berkurang. Kenapa discharging current berkurang bukan bertambah? Of course lah. Mula-mula dia fully charged kan? Mula-mula fully charged. Of course, is the current a lot flowing to discharge the capacitor. Sampai dia sudah fully discharge, ya? Maksudnya charge sudah kosong. Masih ada current flow kah? Masih ada still got current flow in discharging the capacitor? Tak ada sudah kan? Tak ada sudah current sebab sudah fully discharged. Ya? The capacitor sudah fully discharged. So tak ada sudah current yang flowing in the circuit. Ya? No more charge to discharge. So current also becomes zero lah when that means what? That means current stop flowing. Yeah, I equal to 0 when capacitor is fully discharged or neutralized. No more charge to discharge. It's fully neutralized. No more current flow. Stop flowing. Okay, so remember, current stop flowing when capacitor fully charged. Kalau dia fully charged, current stop flowing. Yeah, when capacitor fully charged, current stop flowing. When capacitor is fully discharged, current also stop flowing. Macam contoh ni lah kelas. Macam contoh air ni. Ya, ambil contoh air ni. Ya, contoh air ni. Okay, talking about tangki air yang penuh. Tangki air yang penuh kan? Capacitor yang fully charged. Fully charged. Okay, anggap ini sebagai initial. Lepas tu kita flush. Kita flush sebab kita sudah habis bisnes kita. Sudah habis bisnes kita. Kita selalu mengamalkan kebersihan. Kita flush. Flush lah, flush. So apa berlaku bila flush, kelas? Apa berlaku bila flush? Air keluar, betul tak? Air keluar bila kita flush. Flush. So maksudnya bila kita flush, air keluar. Air banyak keluar. Air banyak keluar kan? Bila kita flush. Flush itu maksudnya discharge, kan? Bila air itu keluar, dia sedang discharge. Discharge. Kalau sudah air semua sudah keluar semua, tiada setitik pun dalam tangki air, ya. So that means it become the empty capacitor already, kan? No more charge. The charge becomes zero, kan? Masih ada air tak? Kalau the charge become empty, no more water, current becomes zero. Understand? But initially current is maximum I0. Maximum I0. When you flush, the moment you flush, I0. When fully discharged, no more current. Ya, boleh letak beginilah. Ini Q initially Q dia Q0 maximum. Ya, initially apa? Macam mana tulis? Initially charge-nya Q0 iaitu maximum. Voltage-nya pun capacitor voltage pun maximum. Tapi finally capacitor zero, charge zero, voltage capacitor pun zero. No more current flow, ya, no more current flow. So current pun zero. No more air sudah habis keluar. So tak adalah air sudah, kan? Begitu. Okay? So tak ada air sudah. Okay? So understand lah, class? So in the end, conclusion dia, can you see the pattern? Charging and discharging. What is the pattern, class? I just want you to see the pattern enough. Charge of capacitor, okay? Voltage of capacitor, also the voltage for resistor. Okay, just want you to remember this thing lah. Okay, remember this thing. And voltage for resistor and the current flow. Okay, class. Charging process. What happened to the charge, class? What happened to the charge? Increase. Voltage of capacitor increase. Voltage of resistor decrease. Current decrease. Okay? Now, voltage of for discharging process, what happened to the charge? Decrease. Capacitor decrease. Resistor sebab voltage resistor sebab dia sama dengan capacitor. So dia pun decrease. Current ini pun decrease. Ya, current decrease. Discharging. So apa-apa pun charging or discharging, current tetap decrease. Current tetap decrease. Current tetap decrease. Macam itu, ya. Cuma yang bezanya charging Q dan V meningkat, discharging Q dan V menurun, ya. But for current, tak kira charging or discharging, the current always decrease. Begitulah, macam inilah. Bila nak charging proses, current banyak masuk untuk fill up the capacitor. So bila water tank dah penuh, current stop flowing. Yeah. When we want to discharging, bila kita flush, a lot of current come out until tangki sudah kosong, no more current. Yeah, no more current, tak ada lagi air keluar. No more current come out. So air become zero also. So like this lah. This is what it means lah by today's lesson. Okay, class? Understand? Understand, class? Okay, so cakap 5 minit dah begitulah ya panjangnya. Tapi saya dah habis lah ya, almost 1.3 2.3 kita banyak sudah cover. Almost finish chapter 2 sudah. Almost finish ya. Okay, so that's all for today lesson ya. I will upload this video later on. Okay, thank you ya for listening. Okay, bye. Okay.
Thank you, sir.
Yeah, thank you.